Hello students, this is Ritesh Mathur from the Department of Mechanical Engineering from Arya College of Engineering and IT. So in this video lecture of engineering mechanics, we will discuss the second method, analytical method, to find out the resultant of a coplanar concurrent force system. Okay, so just for the remember, what is resultant force? It is that force which will create the same effect as on on the body, which will be produced by all given forces. Okay, so the second method is resolution of forces. So first of all, what do you mean by resolution of a force? Okay, so the process of splitting up the given force into a number of components without changing its effect on a body is called resolution of force. Okay, it is generally resolved in along two mutually perpendicular directions. Okay, in fact, the resolution of force is the reverse action of the addition of the component vectors. Okay, means it is the resolution is the opposite of your composition of forces. Okay, now what is the principle of resolution? It states that the algebraic sum of the resolved part of a number of forces in a given direction is equal to the resolved part of their resultant in the same direction. In general, the forces are resolved in the vertical and horizontal direction. So as we can see in the figure that the force F is inclined at an angle theta with the x-axis direction. So in the x-axis it will be F cos theta, and the second component along the y direction will be F sin theta. So remember that uh, the angle makes the angle the force makes the angle with the plane, that the component parallel to that plane will be cos of that angle. Okay, so suppose these are two cases. In case number 1, the force F is acting at a point, and these are along the x and y direction. Then the F is making angle theta with the x direction, so it is F cos theta, and the other one, that is y, is your F sin theta. This is Fx and Fy. But now suppose the body is at an inclined plane. So here the the this plane is inclined at an angle theta with the horizontal. Then the W, that is your weight of the body, the weight will act always perpendicular downward. Okay, so for this the forces will be one component will be parallel to the plane and other one is perpendicular to the plane. Which plane? Inclined plane. Means one is parallel to inclined plane and other one is perpendicular to your inclined plane. So perpendicular is your Wn and parallel is your Wp. So if the plane makes an angle theta, then the vertical component of your force W, that is Wn, will make an angle theta with the vertical component. So in this the Wn, that is your component, is making an angle theta with the plane which is perpendicular, axis perpendicular to the plane. So Wn will be W cos theta and Wp will be your W sin theta. Now, what is the method of resolution for the resultant force? There are some steps. The first step is resolve all forces horizontally and find the algebraic sum of all horizontal components, that is summation Fx. Number 2 is resolve all forces vertically and find the algebraic sum of all the vertical components, that is summation of Fy. The resultant R of the given forces will be given by the equation R will be equals to root under summation of Fx square plus summation of Fy square. Then the last one is the resultant force, means your we can say the position of the resultant. So the resultant force will be inclined at an angle theta with the horizontal, such that tan theta will be equals to summation of Fy upon summation of Fx. Now how will you find out that the uh, your resultant will act in which quadrant? So when summation Fy is positive, the resultant makes an angle between 0 degree and 180 degree. But when sigma summation fy is negative, then the resultant makes an angle between 180 degree and 360 degree. Okay. Similarly, when summation fx is positive, the resultant makes an angle between 0 to 90 or 27 to 360. But when fx is negative, the resultant makes an angle between 90 degree to 270 degree. We will discuss this thing by this example, that f1, f2, f3 and f4 all are making an angle alpha 1, alpha 2, alpha 3 and alpha 4 with the horizontal. Then the component along x direction of f1 will be f1 cos alpha 1 towards right and f1 sin alpha 1 vertically upward. For f2, f2 cos of alpha 2 towards left and f2 sin of alpha 2 vertically upward. For f3, the component will be f3 cos of alpha 3 what towards left and f3 sin of alpha 3 vertically downward. For f4, the f4 cos of alpha 4 towards right and f4 sin of alpha 4 vertically downward. So summation fx, that is your algebraic sum of all horizontal forces. For this, the force towards right will be positive and towards left will be negative. So for this one, f1 cos alpha 1 minus f2 cos alpha 2 minus f3 cos alpha 3 plus f4 cos alpha 4. And for the summation of all vertical forces, this will be f1 sin alpha 1 plus f2 sin alpha 2, f3 sin alpha 3 negative because it is downward, and f4 sin alpha 4 negative because it is again downward. So r will be equals to summation fx square plus summation fy square, and tan theta will be equals to summation of fy upon summation of fx. So a body is in under coplanar system of concurrent forces in equilibrium if resultant is 0, summation fx is 0 and summation fy equals to 0. Let us take one example. So you will have to determine the magnitude and direction of the resultant of the following set of forces acting on a body. 200 Newton inclined 30 degree with east towards north, 250 Newton towards the north, 300 Newton towards northwest and 350 Newton inclined at 40 degree with west towards south. Okay, so first of all we will draw the free body diagram in this. North, south along your y direction and towards right east and towards left it is west. So 200 Newton inclined 30 degree with the east towards north. So it is 200 Newton away from the center and 30 degree from east. Then 250 Newton towards the north. So along your y direction in the upward direction it is 250 Newton. Then 300 Newton northwest means 300 Newton northwest means 45 degree in between. So that's why 300 Newton 45 degree with west, and then 350 Newton inclined at 40 degree with the west towards south, means it is basically a force of west which is inclined at an angle of 40 degree towards south. So in this way we have prepared the free body diagram. Now resolving all forces along x direction, we will get 200 cos 30 plus 250 cos 90 plus 300 cos of 135 plus 350 cos of 220. So we will get minus 307 Newton along OX dash, means so your summation fx is negative. Then resolving all the forces along y direction, it is 200 sin 30 plus 250 sin 90 plus 300 sin 135 plus 350 sin 220. You will get positive 337.4 Newton along OY. Okay, so and magnitude is r equals to root under summation fx square plus summation fy square. We put the value and we get 456 Newton. Now since fx is negative and fy is positive, so the resultant will lie in the second quadrant. Okay, and its inclination is theta dash with OX dash. Okay, instead of OX. So theta dash will be equals to tan inverse mod of summation fy upon summation of fx. So the value is 47.7 degree. Okay, so the inclination of the resultant, if I find out that with the OX, then this will be equals to 180 minus 47.7, that is your 132.3 degree. And suppose in the problem they ask that also find out the equilibrium force, then the equilibrium force will be equal and opposite force to your resultant. Okay, so that's all. Thank you.